Hello, hi everyone, welcome back to the channel. So today in this video lecture we'll be solving this problem, counting paths, yet another problem in the tree algorithm series. So before you watch this video, make sure to attempt this problem by yourself because that will help you to tackle the problems when similar problems appears next time, right? So just watching video solution for any problem will not help. Just try to solve this problem by yourself, give it a time and then come back to this video. Okay, so you're given a tree consisting of n nodes and m paths in the tree. The task is to calculate for each node the number of paths containing that node, right? So let's better understand the statement using an example. So basically we have a tree. So let's take the tree 1, 2, then 1, 3, then 3, 4, then 3, 5. So let's take this tree. And now you can see that we are given n nodes and we are also given some paths. We are given 5 nodes, then we have 4 edges which are the edges of this tree, and then we have 3 queries for the paths. Basically we are given the endpoints of the path and we need to calculate and we need to find how many times each node appears in these m paths, right? So the paths are 1 3 2 5 1 4, 1 3 2 5, and then we have 1 4, right? So these are the paths that we have. Now let's take the very first path between 1 and 3, this one. Okay, so we can see that in this path the node number 1 appears once. Okay, so we have node number 1 and now we have node number 3. So this is the path number 1. Now let's see the path which starts at 2 and ends at 5, the path between 2 and 5. The path is like this: 2, then 2 to 1, then 1 to 3, then 3 to 5, like this. That means node number 1 exists in this path as well. So this is path number 2. Let's take the third path, which is a path between 1 and 4. The path is this. And now let's see for each node in how many paths the node exists. So let's say that for node number 1, it exists in the very first path, it exists in the second path, and it exists in the third path. So we have answer 3 for node number 1. Let's move to node number 2. So for node number 2, it occurs in path which is second path from 2 to 5, and that's all. So the answer for node number 2 is 1. For node number 3, it occurs in the first path between 1 and 3. It occurs in second path between 2 and 5 because 2, 1, 3, 5, 3 is there. And it occurs in the path between 1 and 4, that is 1, 3, 4, right? 3 is there. So it occurs in 3 paths. Node number 4, it occurs in path 1, 3, 4, this one. It is not there in this path from 2 to 5, that is 2, 1, 3, 5. It is also not there in the path from 1 to 3, that is 1, 3. So the answer for node number 4 is 1. It is only present in one of the paths. And node number 5. Node number 5 is present in this path from 2 to 5, 2, 1, 3, 5. It is present in the path from 2 to 5, that's all. It is not there in any other path. So the answer is 1 for node number 5. So this is my answer array which I require at the end of the function, at the end of the solution. So how are we going to get this answer? Let's see that. Again, think about it, give it a time, and then come back to the video solution, because without giving it a thought for maybe half an hour or an hour, if you just watch the solution video by reading the problem statement, this will never develop your problem solving skill. And let's see, let's solve the problem. The first observation to solve this problem is that we know that between any two nodes, take any two nodes of the tree, since it is a tree, we have unique path. Okay, we have only one path between those two nodes of the tree, like here 2 and 5 just one path, 1 and 4 just one path. And the second observation is that take any path, right? Observe any path. So since we are solving the problems of trees and recently we have learned about the concept of lowest common ancestor. So while calculating the path in a tree, while finding the path in a tree, and there is a unique path, and that unique path must go through the LCA of the two nodes. And observe it. Let's take the very first path, the path between 1 and 3. The LCA for 1 and 3 is 1, right? The LCA for 2 and 5 is 1. The LCA for 1 and 4 is also 1, right? So all of these paths goes through the LCA. You can see the path between 2 and 5. I move from 2 to 1, then from 1 to 5 all the way down. This is how we have a path between any two nodes in the tree, right? So the second observation is that there is a the path, the unique path, the path goes through LCA, right? Now, how this will help us to calculate the number of nodes, number of times a node occurs in the path, or in how many paths a node occurs. Simply we just the target is basically to traverse the path. If we somehow traverse the path, like just a thought process, let's say take the path between 2 and 5, the path is 2 1 3 5. If I traverse all of the nodes in the path, like move from 2 to 1 and then from 1 to 3, then from 3 to 5, and keep an array, the basic thought process is like this. So we have an array like this, and start from 2, and we have seen 2 in this path, increment 2 by 1, move to 1, increment 1 by 1, move to 3, increment it by 1, move to 5, increment it by 1. Done. We are done. We have known the occurrence of each node in this path. Move to the next path between 1 and 4. So move from 1, start from 1, increment it by 1, it becomes 2. Move to 3, increment it by 1, becomes 2. Move to 4, increment it by 1, it becomes 1. Now, the third step is between 1 and 3. So we have 1 and 3. So move from 1 to 3. So start from 1 and increment it by 1. It becomes 3. Move to 3, increment it by 1. It becomes 3. So we have 3 1 3 1 1, which is the answer array. We have known how many times, in how many paths a node particularly appears. And that's the target. So basically that's what we have to do. If we can somehow traverse the path, then the problem can be solved. How we can do that? The most obvious answer which our mind from 3 we have 5. So for the path between 2 and 5, from 2 I have to move to the LCA, and then from 5 I have to move to the LCA. So let's say for two nodes A and B, move from A to the LCA and then from B to LCA, and keep counting all the nodes. So for node 2, start from node 2 and increment the answer here by 1. Okay, and the answer here at this point will also be 1. Now start from 5, the answer will increment by 1, and the answer for node number 3 will increment by 1. Now move finally to node number 1, the answer will increment by 1. But you can see that here we are getting 2, but we should not get 2 here. Why? Because this is a single path, and 1 appears exactly once in this path. So we are incrementing the LCA twice. That means we have to move from A to L while incrementing all the nodes, the frequency of all the nodes by 1 in this array, and I have to move from B to the node which is the direct child of the LCA but not the LCA itself. So that is from 5 to just 3, and do not move to node number 1. So move from 2 to 1 and move from 3 to 5 and keep incrementing the frequencies. So I'm just explaining the thought process, how we can think about the solution now, and keep incrementing the values. So move from 1 to, it becomes 1, move from 2 to 1, it becomes 1, then from 5 it is 1, then move to 3, it is 1, and now we do not have to move to the LCA. Okay, and in this fashion I have covered all the nodes of the path in the frequency array, in this array, right? Now let's take the second path, which is which is between node number 1 and node number 4. So take the second path between node number 1 and node number 4, this path from 1 to 4. So what is the LCA? The LCA is this, which is node number 1. Now move from node number 4 to this LCA. So increment 4 by 1, increment 3 by 1, it becomes 2, increment this LCA, which is 1, by 1, it becomes 2. Fine. Now let's move to the next path, which is between 1 and 3. So what is the LCA of 1 and 3? It is 1. So increment 3 by 1, it becomes 3. Now move to 1 and increment it by 1, it becomes 3. And that's all. That's my answer. The answer would be, for node number 1 we have 3, for node number 2 we have 1, for node number 3 we have 3, for node number 4 we have 1, for node number 5 we have 1. So this is the thing, right? We have got our answer array prepared for this tree. So how we can implement the solution to this problem? We know that starting from the nodes which we are given, the nodes A and B, we need to move up to the LCA, or we can also move the other way around, that is from LCA move to the node A, and from this node, let's call it K, from K move to node B. So there are two ways to move and to traverse the path, right? So what is the implementation? The implementation seems a little tough, but let's see that. So let's take a tree, 1, 2, 3, 4, 5, 6, let's call it 7. Okay, so let's take this tree and let's see the path. The first path which I want to find is between 6 and 5. Okay, the first path is between 6 and 5. So the path between 6 and 5 is, now find the LC. The first step is find the LC of 6 and 5, because the path must pass through the LCA. So the LCA for 6 and 5 is 1. So I have to start from 6, I have to move up to 1, then I have to start from 5, I have to move up to 3. Okay, because I cannot count the LCA twice. So what is the strategy to record all of the nodes in the frequency array? So let's call this our, so let's prepare a frequency array, or let's call it a answer array. One, 2, 3, 4, 5, 6, and finally we have 7. Okay, so this is the thing. So start from for the very first pair of nodes, that is node number 6 and node number 5. Start from 6 and move up to the LCA. Start from 5, move up to this node 3, and keep incrementing the values of each node in this array. Okay. Okay, so for the very first node, for the very first pair of nodes, 6 and 5, what I will do is just increment the value of 6 by 1, increment the value of 5 by 1, and that will give us 1 here, that will give us 1 here. Okay, now the next step is for node number, let's take the next path between node number 4 and node number 5. I want to find this thing. So increment the node value for 4 by 1 and increment the node value for 5 by 1. Okay, so for 4 we have 1, for 5 we have 2, right? For 5 we have 2, for 6 we have 1, right? Now this is the frequency of each node that we have recorded. Let's take one more path. The path is between 7 and 5. So for 7 increment it by 1, for 5 increment it by 1, it becomes 3. Okay, so we have these 3 paths, and for 5 we have plus 1, and for 7 we have 1. Fine. Now let's see how we can get the frequency of each node, that is how many time, like in how many paths each node appears. To do so, all we have to do is just pass on these frequencies up till the root node, right? That's all we have to do. So from 6 move to its parent, which is 2, and pass on the frequency, which is 1. Now from 2 move up and pass on the frequency, which is 1. Do the same for this. From 7 move up and pass on this frequency, it becomes 1 plus 1. Now move up, which is to the node 3, and pass on this frequency, it becomes 2 here. Now from 5 move up and pass this frequency, which is 3, so it becomes 5. Now from here move up, which is node number 1, so it will be 5 plus 1, 5 plus 1, which is 6. Okay, now we can see that the answer that we have got is, for node number 1 we have 6, for node number 2 we have 1, for node number 3 we have 5, for node number 4 we have 2, for node number 5 we have 3, for node number 6 we have 1, and for node number 7 we have 1. So we have 6 1 5 2 3 1 1, like this, and that's my answer array. Is it the answer array? Is it right? Let's see. Let's explore the path between 6 and 5. The path is 6 2 1 3 5. Every node appears 1, so increment the frequency of all the nodes by 1. Six, 2, 1, 3 and 5. Fine. Now move to the next path between 4 and 5. So from 4 to 5, 4, increment the frequency of 4 by 1, increment the frequency of 3 by 1, it becomes 2, increment the frequency of 5 by 1, it becomes 2. Now the next path between 7 and 5, increment the frequency of 7 by 1, the frequency of 4 by 1, the frequency of 3 by 1, it becomes 3, the frequency of 5 by 1, so it becomes 3. Okay, but we can see that the answer here, it includes 2 and it includes, the answer is little bit different from what we generated here. What we have generated is 6 1 5 2 3 1 1. The answer is 1 1 3 2 3, right? 2 3, because node number 5 appears 3 times. Yes, 4 5 6 5 7 5 1 1. So we can see that first value and the third value do not match. The rest of the values are matching. Why? what is special in these two values? What is special in 3 and 1? Observe. Observe node number 1. What is special in this? For 6 and 5, it is the LCA. Okay. For 6 and 5, it is the LCA. What is the special in node number 3? For 4 and 5 and for 7 and 5. For both of these paths, it is the LCA. Rest of the nodes gives me the same value. But the value here for the LCAs is different. What is the problem? What I am doing here, the problem is simple. What I am doing, I am increment the frequency of 6 by 1. So what happens is the path is this 6, 2, 1, 3, 5, and let's record this path 6 and 5. It is 1. I increment the frequency of 5 by 1. Now the frequency of 2 becomes 1 because this is also in the path, and the frequency of 1 becomes 1 because it is there in the path. And I do the same for node number 5. I move up, pass on the frequency, it becomes 1 for node number 3, and I add the frequency here as well. I'm adding the frequency again, although I didn't have to. That's why the answer is 6. The answer I'm getting is 6. But the answer which I must get is 1. So how can I handle that condition? To handle this, what I will be doing is just decrement the extra frequency which you are recording. That's all. So whenever you calculate the LCA, incrementing the just decrement increment the values for the AND nodes by 1, and then decrement the value at the LCA by 1. Okay, that's the idea. So let's take a tree, let's take a sample tree 1. Let's take this same tree. It was 1, 2, 3, 4, 5 like this. 1, 2, 3, we have 4, we have 5, and here we have 6, and here we have 7, right? This is the tree that we are having. Okay, so in this tree we can see that all we have to do, how we will prepare this array. The idea is simple. 1, 2, 3, 4, 5, 6, 7. So let's first take this path 7 and 5, or it was 6 and 5. I think it was 6 and 5. The first path was, or it was 6 and 5. 6, 5, 4, 5, 7, 5, right? So 6, 5. Increment the frequency of 6 by 1. Increment the frequency of 5 by 1. Decrement the frequency of their LCA by 1. Okay. So what is the LCA? The LCA is 1. So it becomes minus 1. Now take the second path, which is between 4 and 5. Increment the frequency of 4 by 1, the frequency of 5 by 1, which becomes 2, and decrement the frequency of their LCA by 1. It becomes minus 1. Take the third path, which is between 7 and 5. Increment the frequency of 7 by 1, increment the frequency of 5 by 1, it becomes 3, and decrement the frequency of these two nodes, which is 3 by 1. So it becomes minus 2. Okay. That's the thing. What is the next step? The next step is basically use DFS to pass on these frequencies to the parent nodes. Okay, so we can see the frequency of node number 6 is 1. For 4 it is 1. For 7 it is 1. For 5 it is 3. For 3 it is minus 2. And for 1 it is minus 1. For 2 it is 0, right? Now what I will be doing is I will be running a DFS from node number 1, and in that DFS, like start a DFS from node number 1, then I will, so let's call it DFS 1. Now move to node number 2, move to node number 6, and now while moving back to node number 2 from node number 6, you increment, like you add the frequency which is here at node number 6 to the frequency of node number 2. So what is the frequency 6? It is 1. So add it here. It becomes 1. Now move to node number 1. Add the frequency of node number 2 to node number 1. What is the frequency of node number 2? It is 1. So add it to 1. Add it to 1. It becomes 0. Now move to node number 3. Now from 3 move to 4. From 4 move to 7. Now from 7 move back to node number 4. So at node number 4 add the frequency at node number 7. It becomes 2. Now from node number 4 move back to node number 3 and add the frequency of node number 4 and it becomes 0. So the frequency of node number 3 becomes 0 because the value for node number 4 is 2 and the value at node number 3 becomes 0. From 3 move to node number 5 and now from 5 move back to node number 3 and add the frequency of node number 5 to the frequency at node number 3. So it becomes 0 plus 3, it becomes 3. Now move back to node number 1 and add the frequency of node number 3 and it becomes 3. Right? So what I am getting is, I am getting 3, 1, 3 and then I am getting 2, 3, 1, 1. Is it equal to the answer array which we derived? The answer array was 1 1 3 2 3 1 1 1 1 3 2 3 1 1 1 1 3 2 3 1 1. Entire array matches except the one value which is this one for node number 1. Now what is the problem here? Why this value is not matching? It's because observe that while I'm moving from 3 to 1, what I am doing is I'm adding all of the frequencies which I have got till node number 3 because this is the LCA to node number 1 as well. Right? Like I'm adding the frequency which I have recorded here in this path. I'm adding the frequency which I may have recorded in this path between 7 and 5 and all of these frequencies I'm adding to the LCA. So how can I handle this condition? So to handle this condition, what I am going to do is whenever I am decrementing the frequency of an LCA, so let's say while I was calculating the LCA for node number 7 and 5, it was 3. Okay, what I will be doing to handle the condition, since I am analyzing the paths which are below this node number 3, where node number 3 is the LCA, I do not want the frequency of node number 3 to be added to its direct parent, which is node number 1. Why? Because this node appears in all of the paths which consist of the nodes which are below it, 4, 5, 7, right? I don't want the frequency of this node to be added to its parent. To handle that condition, whenever I am decrementing the frequency here, I will also decrement the frequency for node number 1 as well. So when I calculate LCA, L, I will find the direct parent of it, which can be calculated by binary lifting by preparing that up array which we have discussed in the previous videos. So for this element which is up of L0, the direct parent of the LCA, I will decrement the answer. So in the answer array, I will be doing answer minus minus, answer of up L of 0 minus minus, while this is the direct parent of the LCA, right? So that's how we solve this problem. So let's solve this problem by the approach which we have explained, which we have arrived at till now. So I hope you are seeing the thought process. This is the thought process which I use to come up at the solution, and there can be multiple thought processes to solve this problem. Like one may go through entirely different approaches, then finally come up at some unique approach to solve this problem. So that is an entire different journey which you go through when you solve problem by yourself. So that's why you have to solve problems, right? Now from 4 to 5, and then we have 6, then we have from 4 to 7. Now let's see, or let's just see, becomes messy. And So let's record the paths. So the first path is between 6 and 5. Okay, it's 7 and this is 6, right? The first path is between 7 and 5. Or okay, it was okay, it's 6 7. It is right. The first path is between 6 and 5, right? So increment the value at 6 by 1, here by 1, find their LCA which is 1, decrement the value here by 1. Now for this LCA we do not have any direct parent. Fine. So just keep it as it is. Move to the second path which is between 4 and 5. Increment the value at 4 by 1, value at 5 by 1. Now, and decrement the value at its LCA. Now, also decrement the value at the direct parent of this LCA, which is node number 1. So it becomes minus 1, minus 1, minus 1. Now, explore the third path, which is 3, 7 and 5. Increment the value at 7 by 1, the value at 5 by 1, and decrement the value at its LCA by 1. And also decrement the value at their LCA by 1. Right? Now, that's the scenario that we have. So how the array looks like, the frequency array, or let's call it the answer array, it looks like this: 1, 2, 3, 4, 5, 6, 7. So for node number 1 we have minus 3, for node number 2 we have 0, for node number 3 we have minus 2, for node number 4 we have 1, for 5 we have 3, for 6 we have 1, for 7 we have 1. Right? Now start the DFS from node number 1. Move down to node number 2, then to node number 6. Now move back to node number 2, add the frequency of node number 6 to 2, and it will be 1. We'll have 1 here. Now move to 1, add the frequency of 2 to 1, we'll have minus 2 here, right? Because 1 is added to this minus 3. Now move down to node number 3, from 3 move to 4, then move to 7. Now from 7 move back to 4 and add the frequency of 7 to 4, it becomes 2. Now move back to 3, add the frequency of 4 to 3, it becomes 0. Now move to 5, and now from 5 move back to 3 and add the frequency of 5 to 3, and it becomes 3 here. And now move back to node number 1, add the frequency of 3 to 1. So minus 2 plus 3, it becomes 1. So finally the array is 1, 1, 3, 2, 3, 1, 1. So did you get it? What we are doing? Is it the answer which we were expecting? Let's see. Yes, this was the answer: 1, 1, 3, 2, 3, 1, 1. So I hope you got it how we solved this problem. There were a lot of things which we had to think, like the knowledge which we require was the knowledge of LCA, and another observation was that every path of the tree goes through the LCA. Okay, then it was all about logic building. Okay, so let's just jump to the code implementation part. Okay, so let me show you the code for this problem. So this is the code. Here we have, like, I'm calculating the LCA here. We have already learned how to calculate the LCA, so I'm not going through the code again. So this is the function LCA, which takes in u and v, and it gives me the LCA for these two nodes. And here what I am doing, let me explain. Take the number of nodes and the number of paths input, then take the graph as the input. Run this DFS1. What does this DFS1 does? It basically calculates the up array for binary lifting to calculate the LC, right? Now take the m paths input. So here I'm declaring this global array, which is this sub array which stores the answer, and here I'm taking in the input a and b, and then calculate their LCA, increment the value of a and b by 1, decrement the value of its LCA by 1. If this LCA is not equal to minus 1, if this L is not equal to minus 1, that means we have if this is not, if this, that means the LCA is not equal to -1, we have a valid LCA of the node A and B, then we go to the direct parent of that LCA and we decrement the value at that point. Okay, the reason we have explained in the slide. And finally, I run this DFS2 to calculate the subtree sizes. So let me show you this DFS2. This is easy. It basically traverses in a depth first search manner. And when I am coming back, I'm adding the frequency at the subtree. Whatever the frequency that the subtree has, the child node has, is added to the current node. That's all. And finally, I print this sub array as the space separated integers, which returns me my answer for this problem. Fine. So that's just all for this problem, and this was on a little bit trickier side, but if you solve a few such problems, then these type of problems becomes easy for you, and you tend to think like this. So I will see you soon in my next video.